Welcome back to my channel. In this video, we are talking about the application of first order differential equation to temperature. Okay, we have solved the first question, the second question, and this is the third question. And this question says that a body at an unknown temperature is placed in a room. We don't know the initial temperature, okay, which is held at a constant temperature of 30 degrees Fahrenheit. And let's say that if after 10 minutes the temperature of the body is 0 degree Fahrenheit, and after 20 minutes the temperature of the body is 15 degrees Fahrenheit, then find the unknown initial temperature. Now if you look at this question, you see that this question is not cooling, the question is heating. I told you that the modeling of a temperature is of two types. It could be cooling, it could be heating, and this one is heating. So if it is heating, then don't forget the formula. That the formula is that the rate of change, dt over dt, is directly proportional to the change in temperature. And then the change in temperature, since it is heating, the temperature of the surrounding should be higher than the temperature of the body. So we are going to have the temperature of the surrounding first minus the temperature of the body. Why? Because it is heating. But if it is cooling, we are going to have this one first minus this one. Okay, so we are going to have that the T over the T will now be equal to what? Let's use R, not K. R in bracket of the M minus the T. So this is equally positive because it is heating. If it is cooling, we are supposed to be having that the T over the T will be equal to what? Will be directly proportional to what? T minus Tm. Then we'll now have that the T over the T will now be equal to what? Minus R into T minus Tm. Okay? It will not be negative because it is cooling. But in this case, we are not talking about cooling. We are talking about heating. So this is what we are going to be using. So having this, if I open the bracket, I'm going to have that the T over the T is equal to what? RTM minus T. Minus RT rather. Minus RT. So if this one moves to the other side, we're going to be having that the T over the T plus RT is equal to what? RTM. Okay? Now, if you look at this critically, you will see that this is equation of this is linear equation, first order linear equation. If I write the first order linear equation, is given as dt over dt plus p of t is equal to what? Q of t. Now, which means that if I compare this equation, I'll see that the p of t here is the coefficient of t here, which is just r, and our q of t is the right hand side, which is what? RTM. Okay, so the next thing to find is our integrating factor. Our integrating factor is equal to the exponential of the integral of that p of t dt. Okay, this is equal to exponential the integral of p of t here is r. So I'm having r dt. So which is equal to exponential rt. Okay, so now my answer will now be what? T dot integrating factor is equal to the integral of q of t dot integrating factor dt. So I'm having that t dot exponential rt is equal to the integral of this gave me rtm, then multiplied by my integrating factor is exponential rt dt. Okay, so now this is equal to my t exponential rt is equal to the integration of this is differentiate rt to give you r, use it and divide everybody. So I'm having rtm exponential rt all over r plus a constant, and my constant here should be the initial temperature. Okay, that should be your constant. So you see that this is taking care of this. I'm having that t exponential rt is equal to what? Tm exponential rt then plus t naught. So if you divide everybody by exponential rt, I'm going to be having that t is equal to what? Tm is remaining here plus t naught exponential minus rt. Okay, that is my equation. So if this is now my equation, we are going to be seeing that we need to find the Tm, that is the temperature of the, we need to find the, they gave us the temperature of the room is Tm, which is 30. So they say that if after 10 minutes that the temperature of this body is 0, okay, so the temperature is 0 at 10 minutes. So and the room temperature is 30. So I'm having 30 here, plus we don't know the temperature of this body, the initial temperature of this body, exponential the rate. We don't equally know the rate at which it increases, but they say that it's after 10 minutes. So minus 10 times this, I'm going to have minus 10R. This is equation 1. Okay, so let us use the other the second statement. The second statement says that the temperature of the body is 15 after 20. So I have 15 is equal to the temperature of the surrounding is 30 plus T naught exponential minus 20R. Okay, so this is my equation 2. Now if I solve equation 1 and 2 simultaneously, permit me to clean this side. So if I solve 1 and 2 simultaneously, I have that so this one moving here from equation 1, I'm going to have that 30 moving here. I'm going to have that T naught exponential minus RT is equal to minus 30. Okay? And then if this one coming here, I'm going to have that T naught exponential, sorry, not RT, but minus 10R. So this one is giving me minus 20R is equal to this coming here, 15 minus 30 will give me minus 15. So if I divide both sides, I'm going to have that this divided by this is gone. This divided by this will give you exponential. According to indices, it's going to be minus 10R minus into minus 20R because we are dividing. Okay, is equal to this divided by this will give you 2. So I'm going to have that exponential 10R minus minus is plus. So minus 10 plus 20 to give you 10R is equal to 2. So therefore my rate will now be exponential move here to become lane. So 10R will now be what? Lane 2. So my R will now be what? Lane 2 divided by 10. So I'm having that my R, if you use your calculator to do that, you're going to be having that R will now be equal to, where did he find his R? R will now be 0.069. Okay, so if my R is 0.069, to find my T will now be very easy. So we can substitute in any of these equations. So if I substitute in equation 1, I'm going to be having that. If I substitute in any of these equations, let me substitute here. I know that T naught exponential minus 10R is equal to minus 30. So I'm having that my T naught exponential minus 10 times my R, which is 0.069, will now be equal to minus 30. So therefore, I'm going to have that T naught exponential 10 times this will give you minus 0.69 is equal to what? Minus 30. So this one coming down here to have that my T naught will now be equal to what? Minus 30 exponential 0.69. Okay? Dividing both sides by this. If I divide both sides by this, I'm going to have this. So my T naught will now be equal to, I don't have my calculator, so if you press that in your calculator, you are going to be having that your T naught so our T naught is going to be okay. This will help us to get our T naught. Yes. So our T naught is going to be, if you do that, what am I going to get? Okay. So please press this in your calculator. Think I'm getting minus 60. Think I'm getting minus 60. Or minus 30 Fahrenheit. Which of them? Find the initial temperature. I think I'm having, let me get my calculator. Let me pause the video and get my calculator. All right, so if you do this, you are going to be getting that this will now give us minus 60 approximately minus 60. But the problem here is that proportionality constant that I changed to T naught is the problem. So here is not T naught, but it's supposed to be proportionality constant, please. And that's my this thing I changed it. So this is supposed to be proportionality constant. So my formula is that here here is not supposed to be 2 naught but proportionality constant. Okay, so T naught means when T is 0. So to find our initial this thing, which is T naught, is when T is 0. This implies that what? T is equal to 0. So if I put it here, we will now have that what? The T will now be equal to what? Tm. Our Tm is what? 30 plus our C. I hope you know that here is now C. Please, here is C. All these things I wrote as C naught should be C. So our C, which is what we got as minus 60. So which we change here to minus 60 exponential 0 times R, which is 0. Okay, because my T is 0 now. 0 times R is 0. So and anything raised to 0 is 1. So this will now give you, this minus this to give you minus 30. So T naught will now be minus 30. As simple as that. So thank you very much for watching. Please don't forget to like this video, share and subscribe. If you have any question, please drop on the comment section. Bye bye.